Hello everyone, this is Subin Matthew and I have chosen the Kaggle dataset for the midterm project. Mainly because I wanted to understand the implementation of the data. This dataset had two files, the test and the train. There was a third file that was provided also to merely show us the format which they wanted us to submit the resulting file, the results file. The first thing that I did was to go through the data sets to find out what the data looked like. I went through a little bit of exploratory data analysis to see how far age stretched, how far, and so therefore most of the variables that were given are classifiers or factors. Only age and fair were integers. All the others were either factors or just characters. To me, the ticket number and the cabin number was of no value. However, as well as the name, mainly because I could get the ages that were missing through the mice algorithm. I used the CART method, the classification and regression, in order to estimate the missing age values. There are about 1,309 rows in the combined data set, and I combined both of them so that any transformation manipulations that I did would apply to both data sets equally, not have any biases based on that. And the missing data was mainly for age, and there was one missing data for fare. The port of embarkation, to me, at this stage wasn't important. So I was going to let it be missed until at a later time. If I wanted to, I could also use some sort of feature engineering to get rid of that missing data in the port of embarkation. However, I did go ahead with some feature engineering on the other variables. This is a matrix for the mice algorithm that I used for the age invitations. You can see that the passenger ID was included. You can see that the P class, an indication of the socioeconomic status. This SIBSP, which is the number of siblings aboard or parent aboard. The P arc, which would be the parent-child relationships on board, and the fare. These four were used, if you include passenger ID, it would be 5, to estimate age using the mice CART algorithm. The age was imputed 5 times, and then the imputed data merged into the table, into the original data set. Now, I wanted to show you the mice algorithm that I used, the chart, the aggregate chart that I used to identify which ones were missing. You can see that fares missing a little bit, which this indicates one row value missing for fare. But otherwise, age has about 20% missing. And the stratas that are missing within the data frame can be seen here. This is a distribution of the fare, the density distribution of the fare. And you can see that most of the fare falls between 0 and 50. So taking a mean to find a good replacement for the missing value of fare wouldn't be appropriate. So therefore, I took the median. And you can see that here. So I said, look, if there's a missing fare, then take the median. And I separated the particular data set I want median of, because I know most of the fares fall in the third class Southampton embarked passengers. Now, going on, you can see that the imputed data of age is very similar in distribution to the original data set. So I guess I am satisfied for now on how the imputation took place. And if you compare the mice output with the original data set, you'll see that they agree as well to a good extent. After I made sure there were no more missing values present, I continued with feature engineering. Now I wanted to see the relationship between the each of the parameter, the variables and the labels, the target. And so I created a bar chart that plotted, among others, the passenger class, the gender, the parent-child relationships aboard, and the port of embarkation to survived in the training data set. Now, I realized that this is a combination data set where both the test and the train are present. I think the charts would sufficiently show the relationship. You can see that I understood that the survivability of the first class was much higher than the third class. The same with the survivability of female passengers. Going on, if the number of parent-child relationships aboard the ship increased, that means if there was family aboard, in other words, if you were single, you were better prepared to survive. And the port of embarkation survivability decreased if you were embarked from Southampton. It increased if you were from Cherbourg. There wasn't a difference if you were from Queensborough. Now this is univariate. And this goes with what we discovered earlier. If you had family aboard, the survivability decreased. Going further, I also conducted a multivariate analysis with age, gender, and the ports. This particular sim lane here is the two rows that were missing ports of evacuation. I ignored, as I said earlier, I ignored that for now. And I realized that the females in Cherbourg had a much broader age range than the males did. And the only other aspect here I can talk about is in Southampton, the males were a little older. I do not know what to make of this relationship. It doesn't seem like it makes any sense to the final outcome of whether you survived or not. Because by now we are all aware that females survived more than males did. Males were the older males survived more than the younger males did. So I don't see much of a story coming out of this relationship chart that I just drew. I will come back to that later. This is a chart that I drew, that I created in SAP Lumira. You can see I was able to combine the ports as well as I did the same thing that I did earlier, except that the males and the females were stacked one upon the other, just to show the totality of people who survived and who did not, and how much of a percentage were males over the females. If you look at Cherbourg here, the number of people who survived were mostly females, and same thing here in Southampton. The same thing here in